Lab 3, Black Hole Orbit. The purpose of this lab was, given some information about a star orbiting a black hole, find the mass of the black hole. The given information included the star's mass, the change in time, the black hole position, and an Excel file of the star's positions, x and y coordinates, as the star orbits the black hole. I used Newton's law of gravitation to find the black hole's mass. The physics principles used for this model include Newton's second law of motion, V final equals V initial, plus F net divided by mass times change in time, the momentum principle, P equals mv, and Newton's law of universal gravitation, F net equals gravity times mass of the star times mass of the black hole, all divided by r squared. For this model, the calculations for dp/dt are very close to F net, and therefore we will set them equal to each other. So, F net equals F net parallel plus F net perpendicular, and F net equals dp/dt parallel plus dp/dt perpendicular. In the code, I adjusted the mass of the star, position of the black hole, which I called the origin, the change in time, and I initialized the mass of the black hole to 1. I changed the radius of the black hole to be 5e to the 10th so that the black hole will be easier to see in the model. In the loop, we use the formula P equals mv to calculate the momentum. Then we calculate dp/dt by the change in P divided by the change in T. I used the net dp/dt, or net force, to find F and Rs, the net force times r squared. Then I divided that number by the mass of the star times gravity, what I called m and g, to find the mass of the black hole. I also adjusted the arrow scales of the 3 arrows, F net in yellow, F net perpendicular in blue, and F net parallel in black, so that you could more clearly see the direction of the arrows in the model. When I run the code while printing out the calculated mass of the black hole for each time t, this is the result. As you can tell, the mass of the black hole appears to change each change in t, but I think this is simply an error in the position file. When I run the code without printing out each calculated mass, the final position of the star shows that the F net direction is towards the black hole, the F net perpendicular is pointing directly perpendicular from the star, and F net parallel is pointing directly parallel of the star. If I were to calculate the mass of the black hole by hand, I would use the final positions of the star minus the black hole's position squared and add it together for r squared. Then I would multiply the r squared by the net force. Then I would divide that by the gravity times the star's mass to find that the mass of the black hole is 4.53 e to the 31st kilograms. The what does it mean question asks what is the difference between dp/dt and F net. For most calculations, we assume F net and dp/dt are equal to each other, and we use them interchangeably. However, dp/dt is the calculated value, and net force is the observed value. The what-if question asks that if the orbit of the star were to remain the same, could a different mass of the black hole be calculated? No, there is no way to increase the mass of the black hole without increasing the gravitational pull of the black hole on the star, therefore decreasing the star's orbit around the black hole. If the black hole's mass decreased, there would be a smaller gravitational pull and a larger orbit of the star around the black hole.